So we're going to spend one more day focusing on the slope-intercept form of a line, which remember is the form y equals mx plus b. First, you must have a line, which remember, an equation that has no exponents will be a linear equation. And we've seen that if we get positive y by itself on one side, in most cases you'll have two terms on the other side. A term that has x, a term that doesn't. The term that has x tells you the slope. The number in front of x tells you the slope. If there is no number in front of the x, it means that it's a 1 in front of the x. And the slope would be 1. Now remember, slope is rise over run, so even if it's not a fraction, we make it a fraction. A slope of 2 we would write as 2 over 1, because slope is rise over run. To go from one point to another on that graph, you'd rise 2 and run 1. And you continue that pattern for as long as you can. And then we saw that you could make them both negative. Negative 2 over negative 1 is still 2. So you could also rise negative 2 and run negative 1. Go down 2 and to the left 1. So when you have a line, again, an equation that doesn't have any exponents, if you get y by itself, on the other side you normally have two terms. The number in front of x tells you the slope. The constant term, the term that doesn't have x, is just a number. That tells you the y-intercept. That tells you where the graph crosses the y-axis. And once you have those two things, it's really easy to graph. So we'll look at some more examples. Student council rents a portable dunk tank as a fundraising activity. They pay for the chance to hit a target with a ball and dunk a teacher into a tank of water. Relationship between the number of balls thrown x and the profit y can be represented by that equation. Is it a line? Is it a line, Jan? Is that equation linear? Can you help her, Riley? No? I know Brooklyn is just dying to answer. Is that an equation of a line? Sorry? How do you know that? Okay, Brock, your turn to save all the ladies. Once again, you'll be their hero. Princess? Is this equation, 3x minus 2y minus 600, a line? Is it a linear equation? It is a line because there are no exponents. No, you didn't. It is a line because you have no exponents. So here's the next question. You wanted the next question, Princess? Here it is. Is this equation in slope-intercept form? Why not? You do not have y by itself. That is correct. So to put it in slope-intercept form, which is part A is asking us to do, we need to get positive y by itself. Probably the easiest way to do this would be first start by adding the 2y to both sides. It doesn't matter what side the y is on as long as you have it by itself. If you add 2y to both sides, they cancel on the left, and you'll have 3x minus 600 on the right, equaling 3x minus 600 on the left, and 2y is on the right. Chloe, put your phone away. Are we done, Peyton? No, we're not. Take your earbuds out. We don't have positive y by itself. What do we need to do, Cheney, to get positive y by itself? We have to divide both sides by 2, yes. Which means you're going to divide the 3x and the 600 by 2 on the left side. So this gives us positive y by itself on the right. On the left, you'll have 3 over 2x minus 300. which is the same as y equals 3 over 2x minus 300. Now it is in slope-intercept form. Part B says state the slope. What does it represent? So what is the slope here? Kai, what is the slope? That's right. The number in front of x tells you the slope. Whenever you get a line in the form y equals mx plus b, you get m by itself, or y by itself. The number in front of x, in this case is 3 over 2, which is 1.5, is the slope. Now, what does it represent? Slope is the rate of change. Sal, what's changing here? Yeah, the money. The money that they're taking in for their fundraiser. It's going to change at a constant rate of 1.5. Put your phone away, Sal. Or in this case, $1.50. For every one person that pays for the right to dunk their favorite math teacher in a dunk tank, they're going to get $1.50 more. So that represents how much they charge per ball. Okay, so this is the rate of change. So students pay, and I know none of you would want to do that to me, so I don't have to worry about it. Students pay $1.50 per ball. They buy the balls and they throw them at the target. If they hit the target, the teacher hits the water. Okay? Now, part C says, what is the y-intercept? Cherry, what is the y-intercept from this equation? Okay, except it's negative 300. Yeah. So what that represents, this would represent their initial cost. They have to rent the dunk tank. Okay? So this represents their initial cost. If they rent the dunk tank and no students buy balls, that means that X, the number of students, is 0. Well, 3 halves times 0 is 0. And 0 take away 300 is what, Kenzie? 0 take away 300 is negative 300. There'll be $300 in the hole if they rent the dunk tank and no students buy any balls. So this represents, this is the initial cost. If you want, we can say the rent for that dunk tank. That's what it represents. So the break-even point is the point at which the money raised equals the money spent. How many balls must the students sell to reach the break-even point? So another way of looking at this, okay, we are told at the start that X is the number of balls thrown and Y is the profit. To break even, the profit must be 0. We're trying to find the break-even point here, and that will be where the profit equals 0. So we can take the equation, and it doesn't matter which form we use. It's probably easier to use the slope-intercept form of the equation. The only thing you need to be kind of aware of, though, is that if you made a mistake when you took the original equation and got y by itself, if you made a mistake in that process, you're going to get the wrong answer for this step if you use the simplified expression. Okay? Which is why it is probably better to use the original expression. 3x minus 2y minus 600 equals 0. And again, the profit is when y equals 0. So I meant to write that down. I think I said that. But the profit is where y equals 0. So take the original equation and make y equals 0. When you do that, that term essentially disappears because 2 times 0 is 0, and 3x take away 0 is still 3x. So we'll have 3x minus 600 equals 0. And now we need to solve for x. X will be the number of balls that need to be purchased so that the profit is 0, which means they break even. So we need to solve for x, which we would do by starting by adding 600 to both sides. So on the left side, you have 3x by itself. On the right side, 0 plus 600 is 600. And then we would divide both sides by 3 to get the x by itself. And x will be 200 balls. That's how many balls it would take so that they broke even. So that they cover their cost of renting the dunk tank. After that, they're making profit. Before that, they're losing money. So if we want to rent this, again, we have y equals mx plus b. X is the number of balls. Remember, you always need to label your axes. So this is the number of balls. And y is the profit. So this is y, which is the profit in dollars. Now, if we're going to graph this line in slope-intercept form, we have our equation, y equals 3 over 2x minus 300. So we have a y-intercept of negative 300. So our scale needs to be able to allow us to graph negative 300 on our graph. So if I go negative 100, negative 200, and negative 300, and so if we go up by 100, that's 100. The next one will be 200, then 3, then 400, then 5, then 600, then 800, then 1,000, 1,200, and 1,400. So that will represent the profit. Now the number of balls, we know that they have to sell 200 balls in order to break even. So that tells us that, we need to have on our x-axis a scale that allows us to have at least 200 balls and probably more. So once again, I will use a scale of 100 here. So this will be 200, and then 4, and then 6, and then 8, and then 1,000. So it's no problem to put our y-intercept here of negative 300. But it is going to be difficult to rise 3 units and run 2 units because of what scale we have. Okay? Our scale basically is 100 on each axis. But if we have a slope of m being 3 over 2, we can multiply top and bottom of that fraction by 100 and get 300 over 200. That reduces to 3 over 2. And these are numbers that I can use on my graph. I can rise 300 and run 200. I can rise 300 and run 200. That's no problem. I can rise 300 and run 200. Rise 300 and run 200. All these points line up. So we can draw a line going through them. Now, I guess I should back up here and say that we actually can't draw a line through them because this is not continuous data. You cannot sell half a ball. So we shouldn't draw a line through them. Even though it is a linear pattern, this is not continuous data because you cannot buy or sell half of a ball. So we shouldn't draw a line through the points. Okay? So on to the next page. Parents of members of the cheerleading squad rent a hall. They arrange a talent show as a fundraiser. Keen, you with us? You were talking in your sleep. They arrange a talent show as a fundraiser. The relationship between the number of tickets sold, which is X, and the profit Y can be represented by that equation. Is it a line, Stanley? Is that equation give us a line? How do you know? Brooklyn, how do you know? Okay, Jan? Because there's no exponents. That's how we know it's a line. Is it in slope-intercept form, Sal? Why not? Because the y is not by itself. So we need to do that. So we can determine the slope and y-intercept. We need to put it in slope-intercept form. And this one is quite easy to do. All you have to do is add y to both sides. I forgot to write equals 0 here, so let's do that. All you have to do is add y to both sides, and you will have positive y by itself on the right, equaling 12x minus 840 on the left. And again, that will be the same as y equals 12x minus 840. So Ava, what's the slope of this line? 12. And it will represent, again, the rate of change, which in this case would be the increase in their profit as every new ticket is purchased. They are charging $12 a ticket. That's what it means. So M, the slope, is 12, which is the increase in profit per ticket sold. Slope, remember, is the rate of change. And in this case here, Y, we are told, is their profit. X is the number of tickets sold. So Y is increasing by $12 for every new value of X, for every ticket sold. Part B then says, what is the y-intercept? Declan, what is the y-intercept? You want to bet a pop on that? No, the y-intercept is negative 840. You just told me the slope, which you've already done. I asked you what the y-intercept is, and that is negative 840. So this would represent their profit if 0 people buy tickets, which means that they would lose $840 if no one buys a ticket, which means that this would be the cost of renting the hall. So this is the profit if no tickets are purchased the fact that it's negative means they're losing money. So again, this would be the cost to rent the hall. Right, so there's part B. Part C, how many tickets must the parent sell to reach the break-even point? So again, that will be when profit is 0. And we should use the original equation, 12x minus y minus 840 equals 0. In order to break even, y is 0. Y is the profit. And if they're breaking even, y is 0. And again, what happens is that term just disappears because 12x minus 0 is still 12x. So now we'll solve this by adding 840 to both sides. That'll leave us with 12x on the left and positive 840 on the right. What do we do now? Keen to get x by itself. Divide by 12. See, you were saying that in your sleep. So 840 divided by 12 is 70. They would have to sell 70 tickets to break even. Because 70 tickets times $12 a ticket is positive 840. And that'll cancel with the minus 840 that it costs them to rent, and they've broken even. Anything over 70, they're making money. So to graph this again, x, which we are told is the number of tickets sold, that always goes along the horizontal axis. Remember, when you're doing a graph, you must label your axes always. And then on the side, we'll have y, the profit. Which will be in dollars. So we know that our y-intercept is negative 840, so we need to choose a scale on the y-axis so we can see where negative 840 is. So maybe I'll use a scale of 200. So the first line is negative 200, then negative 400, negative 600, then negative 800, negative 7, or negative 1,000, and then negative 1,200. So I use a scale of 200. So the first line above the x-axis is 200, then 400, then 6, then 800, then 1,000, then 1,200, then 14, then 1,600. And we know they have to sell at least 70 tickets to break even, so our scale on the x-axis would need to reflect that as well. We need to choose a scale that allows us to put 70 on there as well as other values. So maybe I'll use a scale of 50. So 50, then 100, 150, 200, 250, 300, and so on. Now, our y-intercept is negative 840. So that'll be, just below negative 800, so approximately right there. And we have a slope of 12, or 12 over 1, which we can't really do on this graph because of what our scale is. But once again, if we multiply top and bottom by 100, that'll be 1200 over 100, which we can put that point on our graph. From here, we can rise 1200. So from negative 800, if you rise 1200, it'll be up to 400, and then rise 100. So that's that point right there. I can rise another 1200, which will be 1600, and run 100. So that'll be that point right there. And even though it's a linear pattern, you should not draw a line through there because this is continuous data, or not continuous, I should say. You cannot buy half of a ticket. Okay, so that was one way that we can graph them by using the slope and y-intercept. But we have another option here. Another way to graph this is to set up a table of values using the original formula. So if we use 12x minus y minus 840 equals 0, we can set up a table of values where we'll just choose some values of x, plug them into the equation to find out what y is. For example, if you sell 50 tickets, what will the profit be? If you sell 100 tickets, and so on, what will the profit be? So this is another option, Princess, that you can use to graph these lines. And what it does is it eliminates the need to change the slope into a number that you can use for your graph. So if I use the slope-intercept form of the line, which is 12x minus 840, the first value of x being 50, so 12 times 50 minus 840, so that's a negative value. They're losing money there because y is the profit. The next point is where x is 100, so 12 times 100, take away 840. So now we're making money there. That's positive 360. 12 times 150, take away 840, is 960. And then the last one is 12 times 200. Take away 840 is 1560. So this would be another option that you could do to graph your line. The point 50 comma negative 240. Now you'd have to do some estimating, but that would be approximately right there. I'm changing color just so we can differentiate between the two sets of points that we used. The next point was 100 comma 360, which we actually already have on our line. It should be a little bit lower than what I have it there because it's just below 400. The next point is 150 comma 960, which should be just below 1,000. That's about right there. And the last point, 200 comma 1560, which we already have. That's that point right there. So you see, we still get the same linear pattern. Those points line up with the other ones that we did. This just gives you another option to sketch a graph. You can create your own table of values, and all those points line up. Okay, now we're done. Sorry, we did part C already. How many tickets to break even? So this slide says, what is the relationship between y and x? Check your answer. In other words, we want to know what equation works for that table of values. So that graph goes through the point 0, 2, 2, 4, 3, 6, and 4, 8. Now, this scale is off a little bit because this shouldn't start at 1, it should start at 0. Okay, so that's why these points don't all line up, because that first point is off a little bit on our graph. Right? So the y-intercept is not positive 2. And that's good because none of the equations have a y-intercept of positive 2. These are all in slope-intercept form. All of these equations. The first equation says a y-intercept of 1, same as the second one. The third one would show a y-intercept of 0, and the last one a y-intercept of negative 2. The first one shows a slope of positive 1, the next two show slopes of positive 2, the last one shows a slope of 4. So to get the right answer here, what we can do is we can take one of the points, like the point 2, 4, and plug them into each of these equations and see which of them works. So for example, when x is 2, the first equation, y would be 2 plus 1, which is 3, not 4. So that one doesn't work. It doesn't satisfy that point 2, 4. The next equation, when x is 2, 2 times 2 is 4 plus 1 is 5, not 4. So that one doesn't work. The next one, though, says that y is 2 times x. 2 times the x value of 2 does equal 4. And that'll work for the other points as well. In each case, the y value is twice the x value. So that is the correct equation for that table of values. Let's just look at the last equation. When x is 2, 4 times 2 is 8. Take away 2 is 6, not 4. Okay? So the correct equation there is equation C. This next one says graph the points, join them with the line. What is the relationship between y and x? So again, it's asking for the equation. And this graph is done right because it has a scale of 1 on both axes, and that pattern is continuous. If we graph the points 1, 4, 2, 5, and 3, 6, it says to join them with a line, so we can do that. And you can tell by looking at the line that m, the slope, is 1, because from any point to the next, you're going to rise 1 and run 1. And b, the y-intercept, is 3. You can see that on the graph as well. So the equation will be y equals 1x plus 3, or just y equals x plus 3. That would be the equation of that line in slope-intercept form. You go to the drink machine and buy 1 cola. Each cola costs $1.50. What if you buy 2 or 3? Well, we can show this on a graph. If you buy 0 cola, the cost is $0. If you buy 1, it's $1.50. If you buy 2, it's $3. 3 would be $4.50. 4 would be $6. So it forms a linear relation. But this is not continuous data because you cannot buy half of a cola. So therefore, we should not join the points with a line because the data is not continuous. It is a linear pattern, but not a linear relation. This next example. Submarines must withstand tremendous pressure exerted on all sides by water. The table shows the linear relationship between pressure and water depth. It asks us to first start by sketching a graph of the data. So we have our table of values already. The first column of the table is the depth in meters. That is the independent variable. Independent variable always goes along the bottom. The first item in the table always goes along the bottom. And the second one, in this case our pressure, in kilopascals will then go along the side. And if we look at the numbers that we have to graph, our depth is increasing by 25 meters in the table. So I'll make the first one 25, the next one 50, then 75, then 100, 125, 150, 175, 200, and so on. And along the side, our pressure, all the numbers in that column end in either a 0, 0, or a 50. So they're multiples of 50. So I can do the same thing on the side. 50, 100, 50, 200, and so on. And as we do this, as long as we get up to at least 850, then we have room to put all these points, which we will. Right, if I continue it, I'm actually going to get up to 1,000. But that's room to put all these points on there. The first point being 0, 0, 25, 350. The next point is 50, 600. The next point being 75, 850. And this is continuous data, because it is possible to have half of a depth in meters. It's possible. So this is continuous data. We can draw a line going through all these points. Oh, I know what I did wrong here. 50. Oh, no, that's right. 100, 125, 150, 175, 200. We're good. 3. Skip 1, skip 1, skip 1, skip 1, skip 1, skip 1. Yeah, we're good. Okay? And again, in this case, you can join the points because this is continuous data. So, part B says, what is the slope of the line? So we got to count the rise and the run. So we're going from 0, oh, I know why this is wrong. I apologize. I knew something wasn't quite right. Because it starts at 0, 100. It doesn't start at 0, 0. I started at 0, 0, and I should have started at 0, 100. That's better. So we want to find the slope of this line. And remember, we learned last week that you can use the slope formula to find slope. y2 minus y1 over x2 minus x1. We just use any 2 points. So if we look at our table up here, we can let the first point be 0.1, the 25, 350 be 0.2. So this is x1 and y1, x2 and y2. So y2 minus y1 will be 350 take away 100. And that's divided by x2 minus x1, which will be 25 take away 0. So that's 250 over 25, or 10. And we saw this last week as well. The rise is the pressure in kilopascals. The run is the depth in meters. So it's 10 kilopascals per meter. That's what the slope represents here. For every meter deeper it goes, the pressure will increase by 10 kilopascals. That's what that means. So that's what the slope is. It's the increase in pressure per meter of depth. So the B parameter, right, this was part B when we found the slope. Part C is asking for the B parameter, which is the y-intercept. It's 100. So this is the pressure that's being exerted on the side of the submarine when the depth is 0, meaning that the submarine is on the surface. So this is 100 kilopascals, which is the pressure on the sub at the surface. So it's sitting on the surface, but the water is still exerting pressure on it. So now that we have these two things, we can write the equation in y equals mx plus b form, where m is the slope, that is 10, and b, the y-intercept, is 100. Now the only thing we might do is maybe change the letters so that they are more representative of our actual situation. Instead of y, it'll be the P for the pressure equals, and instead of x, it'll be D for depth. Don't have to do this, but it just kind of makes sense that the variables will be representative of what the actual situation is. The deepest point on Earth is Challenge Deep in the Mariana Trench. Now you know where the name of the band came from. It's actually a part of the ocean in the Pacific. It's located in the Pacific Ocean. In 1960, the research submarine Trieste reached the bottom of Challenger Deep. At this depth, the walls protecting the two crew members had to withstand approximately 109,300 kilopascals of pressure. What is the depth? So in this case here, using that equation, P, the pressure, is 10D plus 100. So at the bottom of this Challenger Deep, the pressure was 109,300 kilopascals. And we're going to solve for D, which we would do by subtracting 100 from both sides, which gives us 109,200 on the left, equaling 10D. And then our last step would be to divide both sides by 10, which is only going to move the decimal one spot over on the left. It'll be 10,920 meters. That's how deep it is. That's a little over 109 kilometers deep. No, that's not true. 10.9 kilometers deep. Okay, I think we can stop there for now. So there's an assignment to work on, page 29 and 30. I will post the solutions to this one to Google Classroom. You've got a few from last week that have to be handed in, so make sure you get those done and handed in. Okay, but I'll post these ones to Google Classroom so you can check your answers. All right?